Okay, today is lesson 3, radioactive and radiocarbon dating, turning foe into friend. And this is lesson 3 of series 4, creation versus evolution. We have 2 more talks in this series. Next week, evolution and inaccuracies, talking about some of the inaccuracies we're seeing in the textbooks of the public schools and colleges. And then the final one is the dangers of evolution, and then pulling everything together at the end. Today's outline is radioactive and radiocarbon dating, turning foe into friend. I have 4 key points. First, a basis of radioactive dating. Point number 2, there are 3 assumptions that secular scientists use for radioactive dating. And then we'll talk about the 5 evidences for a young Earth from the rate group. And then the final point is turning this foe of millions of years, the rocks are supposedly dated, into a friend of creation. So let's get started on basis of radioactive dating. Every element is made up of atoms with the same unique number of electrons and protons. The number of neutrons can vary, though, in each atom. And what we see here on the screen is carbon atom. There's 3 different types. You have carbon-12 or C12, which has 6 protons and 6 neutrons. There's also carbon-13, which has 6 protons, 7 neutrons. And then carbon-14 is the unstable atom, and that has 2 more neutrons, or 8 neutrons and 6 protons. These 3 different carbon atoms are called isotopes. Atoms in some elements have too many neutrons, so they are unstable isotopes. So the unstable isotope we see is the last one, carbon-14, is unstable. These unstable isotopes may decay by ejecting some of their subatomic particles so as to become stable. The result is they'll eventually turn into a different element, and I'll talk about this later because carbon-14 will go back to nitrogen. So carbon will turn into nitrogen. So this process is known as radioactive decay, and you can use a Geiger counter to detect radioactive elements such as carbon-14 or uranium, and there's a picture on the screen of a Geiger counter. Has anyone ever heard of a Geiger counter? Yeah, I think most of the people have. So decaying isotopes like carbon-14 is the same as radioactive isotopes, or radioisotopes to shorten the term. So decaying radioisotopes eventually result in stable isotopes of different element. Like I mentioned, carbon goes back to nitrogen. Decaying radioisotopes there's 2 types. The parent isotope, and then the stable isotopes turn into daughter isotopes. And minerals, rocks, and fossils contain some of these parent and daughter isotopes. So what are some examples? I have a table here. On the left is the parent isotope that's unstable, like carbon-14 people have heard of. On the right is the daughter isotope. So carbon-14 is the parent. It decays and turns into nitrogen-14. We have other examples. Uranium-238 turns into lead-206. Uranium-235 turns into lead-207. Potassium turns into argon, and rubidium turns into strontium. So these are the decay parent and daughter isotopes. And what I mentioned before, if you look at the periodic table of elements, you see carbon, the atomic weight is 12, and right next to it is nitrogen, 14. So carbon-14, once it decays, it turns into nitrogen-14. So how does this work? Rock is chemically tested for these isotopes at laboratories. But the key assumption is the rate of radioactive decay has remained constant at today's rates. So they assume nothing changed in the past. That's the concept that secular scientists use today. Use today to interpret the past. They don't believe in a global flood. They don't believe the creation. So they assume what we see today has always happened for billions of years. Okay? So what I have on the right is an hourglass. And I want to discuss the hourglass and how it depicts a radioactive decay. So on the screen, you have the sand at the top of the glass, okay? That's called the parent, or the radioactive isotope. So figure that's your like carbon-14 at the top. The sand in the bottom of the glass represents the daughter elements. And you start to see some green in the picture. So the parent has already converted to daughter. So carbon-14, some of the sand is already converted to nitrogen-14. So the falling sand is analogous to radioactive decay. So let's do an example. Say you have this hourglass. It's called an hourglass because it's sand. You flip it over, and it takes 1 hour from all the sand at the top of the hourglass to fit through and go on the bottom, okay? Let's say you tip over your hourglass with all the sand at the top, and you leave it running, and you go out, start your laundry, cook dinner. Later you come back and look at that hourglass. You have half of the sand on top, half on the sand on the bottom. So how long has it taken you to do your chores of laundry and cooking a meal if half is on top and half is on the bottom for an hourglass? Any answers? There you go. Yep, 30 minutes. So it's why? Because you can use it as decay rate. The decay rate for the sand to fall into the bottom glass, for all of it's 1 hour, and you still have half the sand at the top and half at the bottom. Okay, so that's kind of the concept. So the rock's age is calculated by how long the daughter isotopes or atoms have accumulated in the bottom. So this is what geologists do. They measure the amounts, knowing the rate. They can calculate how long the process has started. The process is assumed to start with the rock when the rock formed, so that becomes the age of the rock. However, there's a catch. You have to make assumptions. The radioactive decay only works if you assume 3 assumptions are true. And we'll cover this after I play this next video on radioactive dating by Answers in Genesis. So they'll reinforce what I showed you, and they'll briefly talk about those assumptions, and then we'll go over it in detail. So let's play this video. It goes about 4 minutes, I think, or 3.5.
Nearly every textbook in Science magazine teaches that the Earth is billions of years old, and the primary dating method used for determining this is what is called radioisotope dating, or radiometric dating. Now, this is a reliable method for measuring absolute ages of rocks and the age of the Earth, right? First off, many scientists now regard the age of the Earth to be between 4.55 and 4.6 billion years old. Okay, so if this method is reliable and accurate, why the 50 million year discrepancy? That seems like a lot. But let's get into some details here and see what's going on. Keep in mind that there's all kinds of scientific jargon on this topic, and so we'll just present a very straightforward, simplified version of the process. Radiometric dating is the process of estimating the ages of rocks based on the decay of radioactive elements in them. Basically, there are certain kinds of atoms in nature that are unstable and spontaneously decay into other kinds of atoms. For instance, uranium will radioactively decay through a series of steps until it becomes the stable element called lead. The original element is called the parent element, and the end result is called the daughter element. Radioisotope dating is commonly used to date igneous rocks, rocks which formed when hot molten material cooled and solidified. The dating clock started when the rock cooled. During the molten state, it is assumed that the intense heat forced any gaseous daughter elements to escape. It is assumed that once the rock cooled, no more atoms escaped, and any daughter element now found in the rock is a result of radioactive decay since that rock formed. The decay rate is measured in terms of half-life. That is the length of time it takes half of the remaining atoms of a radioactive parent element to decay. Now, of course, that can be measured in a laboratory, and it is assumed that since we know the decay rate, we can calculate backwards and come up with the age of the rock. But is that all there is to it? Here's where it gets tricky. It's true we can measure a decay rate using observational science, but there's another kind of science that is required to accurately calculate dates for rocks, and that is what we call historical science. Historical science deals with the things in the past, and therefore it cannot be repeated and tested. Dating methods require both types of science, because in order to get accurate rock dates, one would have to accurately know both the decay rate and the initial conditions of the rock sample, right? Since radioisotope dating uses both types of science, we can't directly measure the ages of rocks. There are assumptions involved. For instance, how do we know what the initial conditions were in the rock sample? How do we know the amounts of parent or daughter elements now in that sample haven't been altered by other processes in the past? How does someone know the decay rate has remained constant since the rock formed? The answer is they don't. Let's simplify here and talk about a typical hourglass. Let's say you walk into a room and you see an hourglass with sand at the top and sand at the bottom, and some sand sprinkling from the top chamber to the bottom. Well, observational science would allow us to see and measure the sand, and then calculate how long the hourglass has been running, right? We could make our sand measurements and then calculate when the hourglass was turned over, right? Well, those calculations could be wrong, because we may have failed to consider some major assumptions, like, was there any sand at the bottom when the hourglass was turned over? Has any sand been added or taken out of the hourglass? Has the sand always been falling at a constant rate? Since we did not observe the initial conditions when the hourglass started, and we haven't been watching the sand all the time since then, we must make assumptions. All three of those assumptions can affect our time calculations. Now, of course, there's more to understanding all of this, but enough said.
Hopefully that helps put it together a little bit more. So let's cover the three assumptions of radioactive dating. Assumption number one, initial conditions. And that's basically the known amounts of parent and daughter isotopes at the beginning of the dating method. When you did your hourglass experiment, you tipped the hourglass up, and you assured that the sand was at the top before you did your chores. The problem is geologists were not there when the rock formed at either the beginning of creation or during the flood or after the flood. So they don't know the initial amounts of isotopes or atoms. How did they know there were only uranium atoms? How did they know if there were uranium and lead atoms in the beginning? It would have been, the initial conditions would have been wrong when the rock was formed. Unless you know the initial conditions, you do not know if your clock started ticking with only uranium atoms or parent atoms at the top. Today's geologists have to assume the initial conditions, even though they were not there to measure it when the rock formed. Not knowing and not being there during initial conditions could result in inaccurate rock dating. Assumption number two, closed system. All daughter atoms measured today in the rock must have been derived from the original parent atoms. The problem is you can't have contamination in the rock. What happened during the global flood? You had global floodwaters and tsunami waves of deposits and rocks going on all the lands, covering it 25 feet deep. So the global floodwaters could contaminate your rock sample. So let's apply it to your example where, we're doing the laundry or cooking our meal. While you were out doing your laundry, your mischievous 12-year-old came and lifted the hourglass lid and emptied some of that sand out. The 12-year-old contaminated your hourglass clock. You may have thought you were doing the laundry for 30 minutes, but your clock fooled you into thinking that you were working for 60 minutes because since half the sand was removed, you see all the sand at the bottom, you go, oh, I must have been doing the laundry or cooking for 60 minutes because all the sand's gone. But no, your child took all the sand out. So the result would be inaccurate rock dating if it's not a closed system. But if the global flood came and brought in uranium or lead, then that's not a closed system either. So it would have inaccurate results. Assumption number three, constant decay rate. Radioactive decay must remain constant at today's rate from start to finish. The problem is scientists have been only measuring radioactive decay for the last 100 years. So this is an enormous assumption. It assumes the decay rate, they believe, remained constant for millions and billions of years into the past. And that's a 5 order of magnitude if you go from 100 years to billions of years. So the result would be inaccurate rock dating. And we'll cover this more because this is the one that the rate group nailed, that it wasn't a constant decay rate. And think about it. During the flood, you had the fountains of the great deep opening up. You had all this water shooting up in the atmosphere, causing it to rain for 40 days and 40 nights. There's even some Christian scientists believe that some of that rock went into outer space and turned into like asteroids. Also, remember I showed you the picture of how the Atlantic Ocean was reformed with those ridges? So we had massive decay rates heating up and contaminating it and changing the decay. We'll talk about this. Just giving you a hint from what I'm looking at. So the 3 assumptions: initial conditions, closed system, constant decay rate. None of these assumptions are provable. You weren't there, scientists weren't there to test the rocks in the past. The past can't be observed, measured, or tested. It's gone. That's that historical science realm. It can't be observed back then. It can't be measured or tested. Therefore, these assumptions are not even reasonable because the daughter atoms may have inherited some of the rock when it formed. For example, volcanic gases can cause argon in that potassium-argon radioactive decay. Argon can already be there. So subsequent contamination is common. I have a short video talking about Introduction on Radioactive Decay from Unlocking the Mysteries of Genesis from Institute for Creation Research. And they'll summarize what I just brought up.
Secular scientists say with great confidence that the rocks in the Grand Canyon are in the inner gorge more than 1 billion years old, and these layered sediments between 270 and 540 million years old. They base these estimates on the decay of radioactive elements like uranium and their measurements of how fast uranium decays into lead and helium in the laboratory. These scientists assume that the rate they measure in the laboratory today has been constant since the Earth came into existence. However, about 10 years ago, some of my colleagues and myself found powerful evidence that the rate that uranium decays has not been constant in the Earth's past, but has been as much as 1 billion times higher than we measure it to be today. This has profound implications. It means that this assumption that the secular scientists have been using for the last 100 years is wrong. The implication for the rocks in the Grand Canyon is that these rocks are not hundreds of millions of years old, but only thousands of years old.
The big research came out. RATE stands for radioisotopes and the age of the Earth. It was an 8-year creationist research project from 1997 to 2005. And they concluded that assumption 3, those constant decay rates, is absolutely false. And we'll talk about that at length. Radioactive dating cannot accurately date rocks with millions of years of age. So in this RATE research project, they discovered 5 independent lines of evidence that demonstrate that radioactive decays must have been grossly accelerated during a recent catastrophic geological event, especially during Noah's flood and also when God created the original rocks. But when you have scientists, 95% of them believe in evolution, they've thrown away the flood, they only believe in it, and they threw away that God created the heaven and the earth. So the RATE group, these are a picture of all the scientists. So you got PhD scientists in geophysics, atmospheric physics, nuclear physics, geology engineering, PhD in biology. Also, Stephen Boyd, a PhD in Hebrew and cognitive studies. I'm not going to get into that, but he made a scientific case that Genesis 1 through early parts of Genesis 2 are 99.9% historical narrative. It's not poetry. So it's pretty amazing on that end alone. Okay, so we're going to go through 5 evidences. So hopefully you'll bear with me. But evidence 1, this one is the most unique, I think. Helium and zircons. What are we talking about? Helium is a byproduct of uranium decaying to lead. Every decaying uranium atom produces 8 helium atoms. And then you can see these helium atoms here, the yellow. So there was a deep drilling near Los Alamos, New Mexico for geothermal energy. During the drilling investigations, they intersected granite. Here's a picture on the left of the actual drilling rig that did the borehole, and they went 3 miles deep into the earth. And they extracted granite samples. And you can see a picture here on the right of the granite that was taken out of the ground. And it was located up in the mountains to the west of Los Alamos, New Mexico. And the rock was hot and dry. So the zircon crystals were recovered from this granite. And there's a picture of the zircon crystals on the left. Now, zircon crystals are very small, and you have to use a microscope to see it. And these zircon crystals are about the length of 60 microns. A micron is the millionth of a meter, okay? And a germ is 1 micron. So this is 60 times the width of a germ. Very small. So these zircons contained uranium, lead, and helium. The uranium decays and makes helium and lead. And their supposed uranium lead age, when you decay from uranium and lead using today's rates, it comes out to 1.5 billion years old. But if the zircons were really 1.5 billion years old, they should have lost all the helium. Why? Helium leaks out of zircon crystals because it's lightweight, fast-moving, and slippery. And the hotter the crystal, the faster the leakage rate and more vibrations and movement. So here's helium inside of the crystal, and if I play the animation, it'll leak out of the zircon and go into that biotite granite, all right? But it can't leave the granite. And we can measure this. So how much of the helium leaked and how much stayed? So zircon helium leakage rates versus temperature. We can calculate that. So the helium retained in these zircons were measured. So when you go down 750 meters, temperature is 95 degrees. They went all the way down to 3,930 meters, which is almost 4 kilometers, and that is 2.4 miles deep. That's pretty deep into the earth. And look at the temperature, 277 Celsius, which converts to 531 degrees Fahrenheit. That's more than twice the boiling point of water. That's how hot the rocks were at this depth. So if we look at the temperature versus the helium percentage in those rocks at those different depth layers, when you had it near the top, when it was 95 degrees Celsius, 80% of the helium was still in the rock. When you get down to the bottom at 277 Celsius, 500 degrees Fahrenheit, only 1/10 of 1% of the helium was in there. So the hotter the zircon crystal, the faster the helium leakage. So the rate team predicted the helium leak rates. No one's ever done this before. They were the first one to do this. And how quickly helium leaks out of zircon crystals. So the helium leak rate out of the zircon crystals, it's just basically the leak rate equals the helium lost divided by the time. It's a simple calculation. So they use 2 different times. We'll use a creation model time and put 6,000 years in the bottom. And we'll use a old Earth model of 1.5 billion years and put the time at the bottom. So for 6,000 years of time, the helium leakage rate had to be fast. Okay? For 1.5 billion years of time, the helium leakage rate had to be very slow. So these predictions were calculated in 1998. And what we have here is a graph of temperature on the bottom, on the x-axis, versus helium diffusivity, which is on the y-axis going up, or another way of saying the helium leak rate, okay? So as the temperatures go from, say, 100 or 95 to 277 degrees, they've used the first model, 6,000 years with error bars up to the 95 confidence level. So they used they said how much helium they expected to be using the creation model from 58% to 1/10%. And they said, okay, for 1.5 billion years, the helium leak rate has to be a slower rate. So they modeled it right there. So the observations were taken later. But when we look at it, the difference between the creation model and the old Earth model is a factor of 100,000 between the two models. All right? So their predictions were published in 2000 in this book. But they had a major risk of being wrong. You know, they published it. They said, we're going to measure it after we publish this book and see who's right. Is it the young Earth or old Earth folks on dating the helium and the zircons? So the helium leakage rate in the zircons were measured at a world-class lab at Caltech. And the results, the data fit the 6,000-year prediction, or the creation line. If you look at the blue dots, those are the actual measurements or the data, and see how they fit the red line almost perfectly, the red dashed line. So the experimental data matched the 6,000-year prediction exactly. The 1.5 billion years prediction was extremely wrong. So what they did was, when they measured the amount of helium, they gave a estimated age of the helium leak rate. And the different samples range from 7,270 to 2,400. So based on the measured rates, operational science at work, the estimated average leakage age is 5,680 years, plus or minus 2,000. So basically they proved that using this clock, helium, it matches the 6,000 years that the Bible teaches. I have a short video, helium versus uranium decay rates, where he talks about these two clocks.
Another indication that there's something wrong with the method involves these little crystals called zircons that we find in granite. And within the zircons, you have uranium-238, which is radioactive. And it goes through this multi-step process where that uranium-238 is transformed into lead, a particular isotope of lead. Now, if you look, for instance, at the amount of lead in the zircons, you can figure out how many years of decay that would be at today's rates. And it's about 1.5 billion years. So if you're looking at the lead in the zircons, you would conclude that it's about 1.5 billion years old. But there's another decay product that occurs in this process, and that's helium. When the uranium turns into lead, you have helium nuclei being produced, basically helium atoms minus the electrons. And so they eventually, along the way, they're going to pick up a couple of electrons, and they will become full-blown helium atoms. Well, these helium atoms, they don't react very well with other substances, and it's very easy for it to leak out of the zircons. If these zircons really are 1.5 billion years old, why is it that we still see large amounts of helium within the zircons? Because if they're really 1.5 billion years old, most of that helium should have leaked out. So here we have a contradiction within a single method. You have two decay products. You've got lead, you've got helium, and they're giving you two different ages for the zircon. And again, how do you resolve that paradox? Well, one way to resolve it would be if the decay rates have changed in the past.
So, as you mentioned, we have a helium diffusion clock used through operational science using the scientific method, where the helium and the zircon leaked into the biotite or the granite, and you can measure that rate through that decay rate. The nuclear decay clock is unproven, that's the clock on the right, and uses faulty assumptions and disagrees with the helium diffusion by 250,000. 6,000 years versus 1.5 billion. You multiply 6,000 times 250,000, you get 1.5 billion years. So both clocks can only be reconciled if the nuclear decay with the uranium going to lead was accelerated 100,000 times. So 1.5 billion years of nuclear decay occurred during the past 6,000 years. Evidence number 2, different radioisotope ages. So they used scientists use 4 major radioisotopes dating methods on rocks, and they're potassium argon, rubidium strontium, uranium lead, and samarium neodymium. And geologists usually only use 1 or 2 of these methods. They assume that all the methods will produce the same age results for the same rock. But RATE used all 4 radioisotope methods on all the samples of the rock units studied, and they used the superior isochron technique, which involves 5 or more samples or minerals in the sample tested. In fact, they went even further. They used 20 samples to avoid accusations of them using light data and produce tighter statistics in the results. So let's review 4 rock units they tested. Here is a diabase sill from the Grand Canyon. This molten rock was squeezed like a toothpaste between sedimentary rocks and is called a sill. The rocks are a diabase, which is like a basalt. And the rate, they sent and did 4 tests. They did the potassium argon, and the test of the rocks came back 841.5 million years old. They used the rubidium strontium technique. It came back 1,060 million years old. The lead came back at 1,250 million years old, and the samarium neodymium came back 1,379 million years old. Do any of these radioisotope ages agree with one another? Do they match? Maybe there's an option E, none of the above. You go from one saying this rock's 841 million years old, and then the bottom saying it was 1,379,000,000 years old. They're supposed to all agree, but they all disagree by dramatic amounts. So there's more. RATE selected rock samples from a series of basalt lava flows in the eastern Grand Canyon, and they came back with 3 different results. Potassium argon came back with an age of this rock being 516 million years. Rubidium strontium came back 1,111 million years, and the samarium neodymium came back at 1,588 million years. The results are terrible. They don't match at all. In fact, if you look at the bottom, it's 3 times longer than the one at the top. These results are no good at all. And they're supposed to all match each other. The third, they used a metamorphosed basalt ancient lava flow, and they came back, and rubidium strontium came back with 1,240 million years, lead 1,883 million years, and samarium neodymium came back 1,655 million years. So you can easily see these dating numbers are not the same. They're not even close. The fourth one, they used some of the granite in Grand Canyon, and the results range from 1512 million years to 1933 million years to 1664 million years. Again, we see a great difference in these results. So multiple radioisotope ages for these 4 rock units are different, and they always disagree. So each of these rock units represent a unique geological event: formation of a sill, metamorphosis of lavas, volcanic eruption of lavas, and crystallization of a granite. So we should have seen the same age with all these radioactive clocks, but they're all significantly different. So, if the radioisotope clocks were accurate, and they're always ticking at the same rate as today, each clock should have been given the same age for each rock unit. Therefore, each radioisotope clock must have been ticking at different, faster rates than today to give different ages. So let's look at one specific example here. The potassium-argon clock and the Cardenius basalt ticked rapidly through 516 million years. The rubidium-strontium clock ticked faster through 1,111 million years. And the Sumerian neodymium ticked even faster through 1,588 million years. So all 4 radioisotope clocks yielded different ages for the same rock. Different ages can be explained if these radioisotope clocks ticked at faster rates in the past and at faster rates than today's measured slow rates. So to conclude, different radioisotope ages for the same rocks are evidence of accelerated nuclear decay, matching the helium clock leaving out of the zircon crystals. I have a short video from Dr. Andrew Snelling, which I used most of his material, where he talks about and summarizes better, does radiometric dating prove the Earth is old? I'll play this.
Does radiometric dating prove the Earth is old?
Does the radioactive dating of rocks prove that the Earth is very old? Absolutely not. We need to understand how these methods work so we can find out the answer to that question. First of all, they're based on the occurrence of radioactive atoms of different elements in rocks. For example, some atoms of uranium decay to lead over time. Atoms of potassium, some atoms decay to argon. Rubidium decays to strontium. And we call them parent atoms decay to daughter atoms. Well, what most people don't realize is that there are 3 basic assumptions that are always used, and none of these assumptions are either testable or provable. Let's run through these assumptions. Number 1, that we know the starting conditions. Well, the geologists assume that there are only parent atoms to begin with. Well, if there were some daughters, they think of ways to measure that and figure it out. But really, we don't know because we weren't there to know exactly what the starting conditions were. Number 2, they have to assume that all the daughter atoms we measure today have been derived by radioactive decay of the parent atoms in the rock. But how do we know? What about contamination? What if groundwater flowed through the rocks in the past, adding or subtracting some of the parent or daughter atoms? So that's another problem. And the third assumption is that the rate of decay has always been constant. In other words, we measure how quickly uranium decays to lead today, potassium to argon, and then the geologists have assumed that that's the decay rate back into the past. So because uranium decays very slowly, they assume it's always decayed very slowly. Now, that again is not testable because we weren't there in the past to see whether the clocks have always ticked at the same rate. And geologists don't always admit to these problems and recognise them. Now, I was involved in a major research project and we found several lines of evidence that led us to the conclusion that the decay rates were much more rapid in the past, that they were accelerated, and therefore the clocks tick so much faster that the millions of years ages telescope right down to short young ages. And so, for example, we took rock samples from the same samples from the same rock layers and subjected them to several of the dating methods all at once. And we got different results for the different dating methods. Now, how could that be? Well, we discovered, as we did with several other lines of evidence, that the best explanation, indeed the only explanation, is that the decay rates were faster in the past. So that while the potassium-argon clock ticked through 516 million years, the rubidium-strontium clock ticked through 1111 million years. And so if the decay rate hasn't been constant in the past, that means the clocks are wrong, and therefore we can't trust these radioactive dating methods. But the interesting thing is, the methods still give the similar relative ages. In other words, rocks down the bottom of the geologic record give older ages than rocks at the top. And that's exactly what we'd expect during the flood. The rocks laid down early in the flood should give you older ages than the rocks at the top at the end of the flood. So whichever way we look at it, radioactive dating, while it's inaccurate, there may yet be a way of using it to confirm what we always knew from our from the starting point we have of God's Word.
The next two are basically visual evidence of rapid radioactive decay. It's called abundant fission tracks. At the bottom of the Grand Canyon, there's volcanic ash bed from a volcanic eruption. And inside this volcanic ash bed or pit is only about 3 inches thick, and you can see the scale on the pen in the left picture here. And that's about 3 inches. Inside the ash pit contains more zircon crystals that contain uranium atoms. Now the uranium atom is so large, over time it can become unstable. It's unable to hold itself together, so it decays. Occasionally some uranium atoms eject particles from their nuclei. Very rarely, the nuclei of other uranium atoms will split, and 2 halves of the atoms will fly apart. This is the basic of the atomic bomb. Nuclear decay process is called fission, and you can see the atom on the left split into 2 atoms. So atoms split apart, and 2 new atoms form. So the 2 halves physically damage that zircon crystal. And under a microscope, these damage trails can be seen, and it's called fission tracks. So if you look on that picture there, you can actually see under the microscope where the atoms split apart and damage that zircon crystal. It's all those little black lines in the zircon crystal. As more and more uranium atoms split or cause fission, more and more fission tracks are produced. So the number of fission tracks is observable physical measure of how much nuclear decay has occurred. So if you know the rate at which the fission process occurs, you can count the number of tracks and use it as an age calculating method. So let's look at 3 examples. Example 1 is Peach Spring Tuff near Kingman, Arizona. And the fission track equals 21 million years worth of nuclear decay at today's fission rate. The Morrison Formation, that's famous for all the dinosaur fossils. We find volcanic ash bed, extract the zircons, and find fission tracks. The fission tracks equal 136 million years worth of nuclear decay at today's fission rate. I'm not saying that there was 136 million years. If you use today's measured rate and extrapolate back, that's the number you get. If we go to the bottom of the Grand Canyon to Pete's Sandstone, which was a volcanic ash bed, the zircon crystals, we have fission tracks equaling anywhere from 75 to 500 million years worth of nuclear decay at today's fission rates. And at the bottom you can see the fissions in that crystal as well. So, and this is at the bottom of the global flood sequence. So we see abundant fission tracks up to 500 million years worth at today's fission rate occur in those zircon grains within the volcanic ash beds in the Grand Canyon and Colorado Plateau region. So the fission track ages match the radioisotope ages of these strata. So conclusions: abundant fission tracks in these rocks are observable physical evidence that abundant nuclear decay, 500 million years worth, occurred during the accumulation of strata during the year of the flood. So nuclear decay had to be grossly accelerated during the flood. So we have observable evidence of fission tracks occurring during the flood. And they happened so fast that it was equivalent to up to 500 million years of so-called rock dating. Evidence 4, uranium and polonium radiohalos. Most granites contain black flaky mica mineral called biotite. And we go to a granite in La Posta, California, east of San Diego. And embedded within these black biotite flakes are tiny zircon crystals. We talked about that already. And crystals contain radioactive uranium atoms. And the nucleus decays, ejecting an alpha particle. And there's a total of 8 decay steps where alpha particles are ejected and uranium atom is transformed into stable lead atom. So we get 1 alpha particle, 2nd alpha particle, and then 6 more decay steps lead to a stable lead atom. When the zircon crystals are large, we already talked about it, it stays in that mica. But when the zircon crystals are tiny, not 60 microns, but 1, the alpha particles are ejected out of the zircon crystal and the surrounding biotite flakes, and they're like tiny bullets going into the crystal. It's similar to firing a gun in a drywall and leaving a hole in it. So ejected alpha particles are like tiny bullets which damage the crystal of the surrounding biotite, discoloring it. In the center here in this picture, you can see a tiny zircon crystal and the discoloration around that zircon crystal because of the radioactive bullets coming out. So the discolored area is called radioactive halo or radiohalo. These are physical evidence of abundant radioactive decay. Each of the 8 steps produce alpha particles or bullets that are ejected at each of the decay steps at different energies. And these bullets travel different distances, producing 8 different halo rings. And here's a picture of it. Fully formed dark uranium radiohalo with 8 rings. When you see this in granite, it means the granite has suffered at least 100 million years of radioactive decay extrapolated at today's rates. So this much decay is equivalent to 100 million years worth of radioactive decay measured at today's rates, as I mentioned. So granites around the world contain these dark uranium radiohalos. We have one in the Lake District of England, the Stone Mountain granite in Georgia. Again, equivalent to 100 million years of radioactive decay measured at today's rate, located in flood sediments. Therefore, they had to occur during the flood in 1 year. In many granites, biotite flakes are found with radiohalos consisting of a small ring next to a very dark uranium radiohalo. In many granites, the biotite flakes are found with radiohalos consistent with 2 rings next to very dark radiohalos. In some granites, biotite flakes are found with consisting of 3 rings next to very dark uranium radiohalos. So these halos were produced by the last 3 decay steps, and it's by polonium. And these polonium, the last 3 decay steps, are very fast, and they were described as a very tiny mystery. There's a 1989 Arkansas trial, deputy director of USGS on the witness stand, and he called it that. So where did the polonium come from to produce this? Only a nearby source is the uranium as decays to polonium in the zircons. They had to form at the same time. So what is the decay rate of polonium? Polonium-218 decays in 3.1 minutes. Polonium-214 decays in 164 microseconds. It decays so fast, it's faster than you can blink. It decays in 138 days. So with these polonium radiohalos, over 100 million years of decay occurred while you were blinked during the flood. So the conclusion on evidence 4, coexistent uranium and polonium in many granites around the world had to form at the same time. And this is observable physical evidence of abundant nuclear decay occurred at an accelerated rate during a single year of the flood. The final evidence is radiocarbon in fossils. Carbon-14 is formed in the upper atmosphere. Cosmic rays collide with nitrogen to form carbon-14. And it collides with the nitrogen and forms carbon-14. And the carbon-14 combines with oxygen to form carbon dioxide in the air. So carbon-14 is in the air that you breathe. It was in the food that you ate for lunch and the animals we eat. So right now we are all radioactive with radiocarbon. And by you eating the food, animals or vegetables, you became more radioactive. But when you stop eating, after you die, that radiocarbon-14 decays to nitrogen-14. So if you want to know how long this decay process takes, well, first of all, if you want to know how old your great-great-grandmother is in the grave, you can go measure the amount of radiocarbon in her bones and compare that with the amount of radiocarbon in your bones when you're alive. Knowing how fast the radiocarbon decays, you can calculate how long she died. So we have equipment today that's so powerful you can count individual carbon-14 atoms. And it's equivalent to 95,000 years at today's rate. The half-life of radiocarbon is 5,730 years. And organic material can only be aged up to 95,000 years and they can't have any more detectable radiocarbon. This is why you'll find secular scientists don't date the fossils if they expect them to be millions of years, because if it comes with radiocarbon in them, they have to be less than 100,000 years. So with a half-life of only 5,730 years, radiocarbon decays so rapidly that even if every atom in the earth were carbon, it would have all decayed away in less than 1,000,000 years, more like 95,000. So secular science research shows organic samples supposedly up to 540 million years old have detectable measurable radiocarbon, and this has been published in journals. Radiocarbon in fossils. So Dr. Andrew Snelling sent samples of dated carbon-14 using carbon-14 dating methods. He sent, and if you use the fossil wood date and the strata, it would age 189 million years in the Jurassic marlstone. And the location was Oxfordshire, England. The fossil wood came back not 189 million years. Using carbon-14, it was only 24,000 years. Looking at the coal, it's supposed to be 250 million years old. The carbon-14 age came back 33,700 years old. He sent another fossil ammonite and wood together. But the carbon-14 age came back 42,390 years for the wood and 48,710 years for the ammonite. So Rate selected 10 coal samples taken from 3 geological ages, Cenozoic, Mesozoic, and Paleozoic. The assumed ages range from 34 to 300 million years. The location samples were obtained from the U.S. Department of Energy Coal Bank, and the analysis utilized a storage unit located at Penn State University for analysis. And they used different samples from Texas, North Dakota, Montana, Utah, Arizona, Kentucky, Pennsylvania, and Illinois. And these 3 coal samples were anywhere from 34 to 55 million years, 64 to 145 million years, and 299 to 318 million years. So all 10 samples contain similar amounts of radiocarbon regardless of the age. And all 10 samples were about the same radiocarbon age. Not 34 to 300 million years, but it came back to about 45,000 years. When was this formed? The global flood in 1 year. The pre-flood world trees covered up and formed coal. They also looked at diamonds. They tested 6 African diamond samples for radiocarbon analysis. The age of the diamonds are assumed to be 1 to 3 billion years old. How can that be? Because the diamonds are the hardest substance on Earth, and they shouldn't have any radiocarbon in them. And you can't contaminate diamonds because they're buried 200 miles in the mantle. And all 6 of those diamonds had similar amounts of measurable radiocarbon. So findings, they found similar amounts of measurable radiocarbon in coal samples, regardless of the assumed age of 34 to 311 million years. And the coal represents pre-flood plants buried during the flood. Therefore, it's not surprising they all yield the same radiocarbon age of 48 to 50,000 years. The diamonds found small amounts of measurable radiocarbon. So the result is the diamonds are 1,000, not billions of years old. They're supposed to be 1.3 billion years old. But they were found 200 miles down in the mantle from explosive volcanic action at the start of the Earth. And the diamonds are the hardest known substance to man and are impervious to contamination. So conclusions, all the coal layers formed at the same time during pre-flood plant materials buried during the flood. The deep earth diamonds formed at the same time as the earth itself. Therefore, radiocarbon found in fossils points that the earth is young. Conclusions, uncalibrated radiocarbon ages confirm the biblical time scale for a young earth and the recent Genesis flood. Conventional ages of millions and billions of years are due to the decay of long-age radioisotopes that were rapidly accelerated during events in the recent past. So the last point is turning this foe into friend. Radioactive decay was rapidly accelerated during the flood. Therefore, radioactive ages should yield relative ages in the correct order. So the bottom rocks will give older age versus rocks on top. When relative ages of rock layers can be determined from geological relationships, then radioisotope dates may be a useful guide. Decay acceleration factors for each long-age radioactive parent-daughter isotope system need to be determined. So the result could be a true absolute age can be calculated by building in these corrective factors from a biblical time scale. So we want to recalibrate the radiocarbon clock. Radiocarbon production is controlled by cosmic ray influx. This in turn is controlled by the Earth's magnetic field. The Earth's magnetic field was twice as strong 1,400 years ago. Remember, we said it's been decaying ever since. Therefore, radiocarbon production rate was smaller than it is today. So, huge volume of pre-flood biosphere carbon buried during the flood contained 100 times more carbon than today. Therefore, the trivial radiocarbon found in fossils and coal could be grossly diluted by all the normal carbon. Radioactive ages are conventionally calculated assuming radiocarbon in the past was produced at the same rate as today. If we correct the radiocarbon age based on slower rates of radiocarbon in the past, then we can correct the dating numbers. Coal beds, conventionally radiocarbon ages of 50,000 years, are grossly overestimated due to burial plants during the flood. Dropping that uniformitarian assumption that there was a flood, we can shorten the radiocarbon age to less than 5,000 years. And the result would provide accurate dates when the plants and animals were alive just before the flood. And devise a recalibration factor or dating scheme for radiocarbon age calculations consistent with the biblical time frame of Earth history would become an invaluable ally. Now I have a conclusion of everything. Conclusion 1. 3 radioactive dating assumptions are not provable because the past cannot be observed and measured or tested. They're not even reasonable. Result in millions of years of ages through unreliable, highly inflated, compared to the 6,000 biblical time frame, usually still match the relative order and relative ages of these rock units dated. The Rate Research Group uncovered 5 independent lines of evidence that demonstrated radioactive decay rates must have been grossly accelerated during the recent global flood. Therefore, radioactive dating methods cannot accurately date rocks and fossils with absolute millions of year ages. These dating methods may be a guide to relative ages of rock layers because older bottom layers would have experienced more accelerated decay and accumulated more daughter isotopes than top layers. Measurable radiocarbon in fossils and deep earth diamonds is consistent with the young earth and the recent Genesis flood. And continuing research into a correction factor for the long age parent-daughter isotope dating systems and recalibration of radiocarbon dates will transfer these methods from foe to our friend. And I'll close with a few Bible verses. Romans 1:18 through 19. For the wrath of God is revealed from heaven against all ungodliness and unrighteousness of men, who suppress the truth in unrighteousness. Verse 19, because what may be known of God is manifest in them, for God has shown it to them. The creation evidence is clearly seen to them. Unrighteous men deliberately suppress the truth. This is what's happening in our public education system. They're deliberately suppressing the true scientific evidence so our youth will believe in evolution. And 1 Timothy 6:20, O Timothy, guard what was committed to your trust, avoiding the profane and idle babblings and contradictions of what is falsely called knowledge. 2 Timothy 4, I charge you therefore before God and the Lord Jesus Christ, who will judge the living and the dead, appearing in his kingdom. Preach the word, be ready in season and out of season. Convince, rebuke, exhort, with all long-suffering and teaching. For the time will come when they'll not endure sound doctrine, but according to their own desires, because they have itching ears, they will heap up for themselves teachers, and they will turn their ears away from the truth and be turned aside to fables. But you be watchful in all things, endure afflictions, do the work of an evangelist, fulfill your ministry. So one comment. When you turn away from the truth of God's word and turn to fables like evolution in millions of years, that's what Paul was warning Timothy about. Endure sound doctrine and don't go after teachers. Turn aside to fable. Thanks for your attention. Okay.